Introduction to Networks. What is a network? A computer network consists of two or more compute devices linked together to share resources and information. The network is the infrastructure that provides the communication path between the compute devices. These compute devices could be personal computers, servers, phones, printers, and so forth. A network's interconnected devices are also commonly referred to as nodes or endpoints. So what does a network do? A network allows users to share files, can provide communication using email, instant messaging, video conferencing, and so forth, and allows for the sharing of devices such as printers and scanners. Before networks, if you wanted to share the electronic information in a computer, it had to be copied onto some sort of media, such as a computer disk. You could then take that computer disk to another computer and use it there. Sneakernet was the slang term referring to the process of physically walking a computer disk from one computer to another in an effort to share the information. This was not an efficient process. By connecting devices together over a network, resource sharing became easier and more efficient. Network connectivity can be accomplished using cables, most commonly Ethernet cables, or it can be done wirelessly using radio signals. Types of networks. Different types of networks can be defined by their scope and scale. The two main types we want to focus on are the local area network, or LAN, and the wide area network, or WAN. Local area networks, LANs, are typically confined to a small geographic area where the devices are within close proximity, such as within a building or a campus. Some typical LAN examples include a home network or a networked office building. Wide area networks, WANs, cover a large geographic area. The devices within a WAN could be spread out between towns, cities, or countries. For example, a large company could create a WAN by interconnecting multiple LANs in offices they have in different cities. A WAN is essentially a geographically dispersed collection of LANs. The Internet is the largest WAN, spanning the Earth. Network connectivity. Although wireless connectivity is growing, most network devices are connected by means of cabling. These cables can be copper wires or fiber optic cabling. Copper wires use electrical signals, are used for short distances, and are less expensive than fiber cabling. Fiber optic cable uses light pulses for communication. Fiber is usually needed for cable runs that go beyond the distance limitations of copper wire. Fiber is also less susceptible to electrical interference and costs more than copper wire. Network devices will have ports, sometimes called interfaces, into which the cabling is connected. An Ethernet cable is the most popular form of copper network cable, and they plug into a port called an RJ45 port. These ports are typically built into network devices, but some network devices accept expansion cards to increase the number of ports. There are a variety of fiber optic cabling options available, depending on different needs such as distance, speed, and so on. Thus, there are a variety of port types for fiber cabling. Network devices capable of using fiber cabling will have empty ports into which an appropriate module, such as a small form factor pluggable SFP transceiver, will need to be inserted. Transceiver is an abbreviation of transmitter-receiver, and this device converts electrical signals to light pulses that travel across the fiber cable. Network layers. In order for dissimilar compute devices and networks to communicate with each other, they need a set of rules. These rules are called protocols. The 7-layer OSI reference model and a similar concept, the 5-layer TCP/IP protocol stack, provide a framework for implementing protocols in layers with control passed from one layer to the next. Here, for your reference, we are showing very high-level descriptions of the 7 layers of the OSI model. You'll often hear the terms Layer 2 and Layer 3 in discussions of switching and routing. Note that switching occurs at Layer 2 and routing occurs at Layer 3. You will also hear the upper layers mentioned together as Layers 4 through 7. These layers are often mentioned together because these layers provide network services and next-generation security features. At Juniper, we can help our customers build a better network. Juniper provides a broad range of innovative networking products that scale from the smallest branch office to the largest data center, all with network security, performance, and simplicity in mind. Defined by simplicity and innovation, the Junos OS is the single operating system that powers Juniper's broad portfolio of physical and virtual networking and security products. Built with over 20 years of reliability, security, and flexibility at its core, the Junos OS runs some of the world's most sophisticated network deployments, giving operators a competitive advantage over other network operating systems. Juniper believes that creating simplicity through engineering is the highest form of innovation. Juniper innovation makes it possible for our customers to connect to everything and empower everyone. Thank you, and good selling.